We are solving question number 28 of GATE 2021 Chemical Engineering paper. Water of density 1000 kg per meter cube flows in a horizontal pipe of 10 centimeter diameter at an average velocity of 0.5 meter per second. The following plot shows the pressure measured at various distances from the pipe entrance. So over here we have been given a plot of the pressure measured versus the distance from the entrance of the pipe. And using this data shown in the figure, the fanning friction factor of the pipe when the flow is fully developed is dash. So in this question, we have been given a horizontal pipe of diameter 10 centimeter. So the diameter of the pipe is 10 centimeter. The average velocity in the pipe is 0.5 meter per second. Then the density of the fluid is 1000 kg per meter cube. And we are measuring the pressure within this pipe at a distance of 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, and 6 meter, and corresponding to that pressure we generate this plot of pressure versus distance. And then we have been asked to find the fanning friction factor in the pipe when the flow is fully developed. So using the data that has been provided, that is pressure and distance, we will find out that in which of this section the flow is fully developed, and corresponding to that section we will find the friction factor, and that will be our final answer for the fanning friction factor. So when we say fully developed flow, that means the velocity profile throughout the pipe will remain constant. That is, velocity profile remains constant, and velocity profile will remain constant. That implies the friction factor will also become constant. So friction factor constant. So we will find the friction factor in each of this section, that is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. And when the friction factor in any of these two sections becomes constant, that is, it will be same, that implies that the flow is fully developed. And for that section, whatever friction factor we got, that will be our final fanning friction factor, or the final answer. So the pressure loss due to this friction, we can write it as delta P by rho is equal to 2FLV square upon D, where F is the friction factor, L is the length of the pipe, or the length of the section, V is the average velocity, D is the diameter of the pipe, rho is the density of the fluid, and delta P is the pressure loss. So this fanning friction factor F we have been asked to find. So the F we can also write it as delta P upon L into D upon 2 rho V square. So this entire term, diameter, rho, and average velocity, will remain constant throughout the pipe. And this delta P we can calculate for each of this section. So ultimately the friction factor will become delta P. In each of this section, the length of the pipe will always be 1 meter. Length of the section will be 1 meter. So this distance is 1 meter. Again, this will be 1 meter. So length also we can calculate it as 1 meter. Then diameter, we can replace the value as 10 centimeter. So that will be 0.1 meter. 1, 2, density is 1000 into velocity is 0.5 meter per second. So this will come around delta P into 2 into 10 raised to minus of 4. So we are having this equation correlating the friction factor with the pressure difference. So now we will be using that to find the pressure difference at each of this section, and corresponding that we will find the friction. So F, so between 1 and 2 we can write this F12 is equal to delta P. Delta P will be 1205 minus 1152, 1205 minus of 1152 into 2 into 10 raised to minus 4. So this will be 53 into 2 into 10 raised to minus 4, that is 0.0106. Now F23 will be 1152 minus 1112. So that is 40, 1152 minus 1112, 40 into 2 into 10 raised to minus 4, that will be 8 into 10 raised to minus 3. So now here we can see that the friction factor within the pipe is changing. So as we move ahead in pipe, the friction factor is decreasing. That means the velocity profile hasn't been fully developed yet. So now we will repeat the same exercise for the other section. That is, we can find F34. So F34 will be 1112 minus of 1074. That is 36 into 2 into 10 raised to minus 4. So it will be 7.6 into 10 raised to minus 3. So 1172 minus 1074 was not 36, or 38. 38 into 2 into 10 raised to minus 4 is 7.6 into 10 raised to minus 3. So now for this 4 and 5 section, we can write this F45 as 1074 minus of 1037. That is 37 into 2 into 10 raised to minus 4 will be 7.4 into 10 raised to minus 3. So also we can say that until here the flow hasn't been fully developed yet, since the friction vector is changing in each of these cases. Now for the last section F56, you can write it as 1037 minus of 1000 into 2 into 10 raised to minus 4 is it. So now it will be 7.4 into 10 raised to minus 3. For the last section, that is 5, 6, we can see that the friction factor is becoming constant. That implies the flow is fully developed, and we can write the fanning friction factor within the pipe, that is F, as the 7.4 into 10 raised to minus 3. So this is our final answer. And from the given option, we can select this option B, that is 0.0074 as the correct answer.